This is a lesson on the combined gas law, and the combined gas law is exactly what the name implies. It is a combination of Boyle's law, Charles' law, and Gay-Lussac's law. It relates volume, pressure, and the Kelvin temperature of a fixed amount of gas. That means that the number of moles are the same. I want to show you a few things, and I'm going to change something. This is the combined gas law right here. All right. Notice it's V1 times P1 divided by T1 equals V2 times P2 divided by T2. You need to memorize that one. As a matter of fact, of the gas laws so far that we've talked about, the Boyle's law, Charles' law, and Gay-Lussac's law, if you know this one, you really know the other three. Let me show you something. I'm going to, over here to the side, write something. If I want to do Boyle's law, it's volume 1 times pressure 1 equals volume 2 times pressure 2. All right, look right here. If I were to get rid of this, I have Boyle's law. Remember Boyle's law, temperature is held constant. So if I were to get rid of that part, then I have Boyle's law. All right, now, okay, let's suppose I'm talking about Charles' law. V1 over T1 equals V2 over T2. Again, if I get rid of pressure, V1 over T1 equals V2 over T2. Combined gas law includes Charles' law. Also, Gay-Lussac's law was P1 over T1 equals P2 over T2. If I were to get rid of volume, now I have P1 over T1 equals P2 over T2, which is Gay-Lussac's law. So, basically, if you know the combined gas law, then you should know the other three laws that we've talked about so far. Now, it is important, if you'll notice here, this statement right here, it is important that you make your units compatible. In other words, if this volume is milliliters, if V1 is in milliliters, then V2 needs to be in milliliters. If this pressure is in atmospheres, then this pressure needs to be in atmospheres. Temperature is always going to be in Kelvin, all right? So you need to be, make sure that you are familiar with that. All right, so combined gas law kind of takes all the other laws into account. Let me give you an example of how to use this. This is very similar to what we've been doing. Here, I'm looking for, I've got the volume of a gas is here at this temperature and this pressure. So if that's volume 1, this is pressure, temperature 1, this is pressure 1. You're looking for volume at this temperature and at this pressure. And I apologize, this should be a degree symbol up here, and this should be a degree symbol up here. All right? So, I have two volumes, two temperatures, two pressures. Automatically, your mind should go to the combined gas law. Volume 1, pressure 1 over temperature 1 equals volume 2, pressure 2 over temperature 2. Let's plug in our numbers and see what we get here. We're going to do 27.5 milliliters at 0.974 atmospheres divided by 22 degrees Celsius. Again, I can't use 22 degrees Celsius, so I'm going to change that to Kelvin by adding 273 to it, and that's going to give me 295 Kelvin. On the other side, V2 is what I'm looking for. P2 is 0.993 atmospheres, and T2 is 15 degrees Celsius. I can't use 15, so I'm going to add 273 to that and get 288 Kelvin. All right, so now I've set up my problem. The easiest way to do this problem then is to cross multiply. What you're going to do is I'm going to say 27.5 times 0.974 times 288 So I'm just going to write that out just so you'll be able to see what I'm doing. All right, equals, I'm going to cross multiply 295 times V2 times 0.993 atmospheres. All right. Now that I've got that, notice that I have V2 over here. I need to get that by itself. So I'm going to divide both sides by the 295 and the 9.993. When I do that, and again, I'm going to write this out. So if you have trouble in algebra, you'll be able to see what I'm doing. I'm going to say 2795 milliliters. Actually, what I'm going to do, I'm going to back up. I'm going to go ahead and solve that. Okay, I'm going to go ahead and multiply these together. So that gives me 27.5 times 0.974 times 288 equals 7714.08. And if you'll notice, no units canceled out. So that's milliliters, atmospheres, Kelvin equals, I'm going to say 295 times 0.993 equals 292.935 times V2. And those units were Kelvin and atmospheres. All right. I want V2 to be by itself, so I'm going to divide both sides by this number. And if I was punching this in my calculator, I'd probably round these numbers off, but I just wanted you to be able to see what I was doing. So over here, all of this cancels out. That just leaves me V2 on this side. Over here, 7714.08 divided by 292.935 equals 26.1337, and it's a long number, so I'm just going to say 26.1. Look what happens. Atmosphere cancels out, Kelvin cancels out, milliliters is the only thing left. Milliliters should be your volume unit, so that is my answer. So that's how I do that one. That was kind of a long problem, but it's, if you'll just go step by step with the algebra, it's pretty easy. Let's look at the next problem. And again, if you're watching this on video, what I would suggest doing is you pause the problem right now and try to do it on your own. And then after you have completed that problem, then see if you got it right by looking at the rest of this video. So I'm going to go ahead and get started doing this problem right now. And what I have here is, this is volume 1 at temperature 1 and pressure 1. Remember, if you see standard temperature and pressure, or STP, they're giving you numbers. You're supposed to know what those numbers are. And you're compressing it to this volume. This is volume 2, and it's going to, this is temperature 2, and you're looking for pressure 2. All right? So again, you have two temperatures, two volumes, two pressures. You're going to use combined gas law. Volume 1, pressure 1, divided by, temperature 1 equals volume 2, pressure 2, divided by temperature 2. All right? Let me doctor that up just a little bit so you'll be able to, so you'll understand what I'm talking about here. That's a 1. All right? I'm going to plug those numbers in. 700 milliliters times pressure. Now, I have 3 pressures to choose from if I'm doing standard. If I have 3 pressures to choose from, what I'm going to do is I'm going to look at my other pressure unit. If you'll notice, here it says, what is the new pressure in kilopascals? So I'm going to use standard atmospheric pressure in kilopascals. And if you recall, that is 101.3 kPa. It's very important that you know that number. And my temperature one was at standard temperature. Well, that is 273 in Kelvin. All right? So, now what I'm going to do now is I'm going to do the other side. Volume 2, I got 200 milliliters. Pressure 2, that's what I'm looking for. I don't know that. And temperature 2 is 30, so I'm going to say 273 plus 30, and that's going to give me 303 Kelvin for my temperature. All right? Again, and I'm going to do this in a shorter step, I'm going to cross multiply, or if you would like, you can solve for this side. I'm just going to go ahead and do my math here, see if you can catch up. 700 times 101.3 times 303. So I've just cross multiplied that. Divide that by 273 and divide it by 200, and I get 391.5 kPa equals pressure 2. Let me real fast just double check my math here. Oh, I got something different that time, so hold on just a minute. Let me change calculators, I think. All right, so I have 700 times 101.3 times 303. Divide that by 273 and 200, and I get 393.5. I'm sorry. So that should be correct now. I hope you don't have any problems with this. This is a little bit bigger problem, but it's just a bigger problem in the number of numbers used, not the difficulty of the problem. Okay, it's just a little bit longer because it's more numbers. Again, if you know the formulas and you remember that your pressure units, your volume units, your temperature units, make sure you're using Kelvin, make sure your units are compatible. Your gas law should be something that's pretty easy for you to do. That's it for this one.